So number one, a football player runs directly down the field for 35 meters before turning to the right at an angle of 25 degrees from his original direction and running an additional 15 meters before getting tackled. What is the magnitude and direction of the runner's displacement? So, a couple things that we know. We have our first displacement. I almost made that an I. 35 meters. Now, our first angle here is just 0. It's our point of reference. Okay? Degrees. My second displacement was 15 meters, and my second angle was the 25 degrees. Okay? Now, this might not seem like a big deal, but this could screw up your calculations later on if you thought that the 25 degrees was the only angle that you have here. All right, so we can draw this representing the movement of the football player. So down the field, 35 meters. Cool beans. Turns to the right at an angle of 25 degrees. Now, which angle is 25 degrees? This one or this one? The first one, the top one. Okay? Because the original direction is our point of reference. And so when we move 25 degrees, we have to kind of pretend that he's going to continue. And then from that original direction, we would move 25 degrees. So this is going to be my angle of 25 degrees. And so, all right, so what is the magnitude and direction of the runner's total displacement? So again, we're trying to figure out how to use our trigonometry skills, our trigonometric functions, in the absence of a right angle. Now, spoiler alert, you can't do it. And so what we're going to have to do is we're going to have to build our own right triangle. That is what we are doing. In order to do that, we need to figure out what the x component of each separate triangle is, and then the y component of each separate triangle, and then we can add those together to create one big right triangle. So, oh, I hope I didn't mess up my ability to show my work here. Okay, so my total change in, my first delta x is going to be the first displacement. I don't know why I keep on making i's. Multiplied by the cosine of the first angle, which is 35 times the cosine of 0 equals 35. Now, if you look at this, we're like, well, no, duh. I mean, it's the same number here. But I'm just pointing out that if you have the correct angle in there, it'll still give you that the x component of this movement is 35, right? Because there's no y component. Right, and so we can say that, and again, I can demonstrate that for you with the y component of that. So again, my initial displacement, my first displacement, and I'll multiply that by sine of the first angle, which what you would plug into your calculator, be sine of 0 degrees. And, spoiler alert, that comes out to be 0 meters. So I have the x component of this first movement, this first displacement, and the y component of this first displacement. Cool. Let's do that again for the second movement. So my second x component is going to be the second displacement times the cosine of the second angle, which ends up being the 15 meters, and the cosine to be 25. This one's going to look great on the screen for you guys. Looks great. Don't worry about it. And that ends up being 14 meters in the calculator. I'll do the exact same thing for the y component of the second movement. Okay, my displacement times the sine of the second angle is going to be 15 meters multiplied by the sine of 25 degrees. I didn't screw it up that time. That ends up being 6.3 meters. Okay? So I have two x components and I have two y components. I will add the two x components together, and I will add the two y components together. And what that is going to give me is a triangle, a right triangle. So my new resulting x component, what does that add up to be? 49. And then my new resulting y is 6.3. And so I'm trying to solve for whatever this resulting displacement is, which is the hypotenuse here. And look, I have a right triangle, so I can use the Pythagorean theorem now. So I'll plug in. I'm running out of room here, so I'll just slide this. Or maybe I'll do it this way. Does that make more sense? I don't know. I don't know what's going on. So my total displacement is going to be equal to the total x squared plus the total y squared, and then square rooted. Now, once we actually do that, it'll turn out to be 49 meters. I may be thinking, wait, that's the x component of my new triangle. Yeah, it is. Why are they the same? Because when you square this value and this value is much smaller compared to this value, so that when you add them together and then square root them, according to the Pythagorean theorem, the addition of this term right here is not significant enough to make us round up at all, right? So it is okay that it comes out to still be 49 meters. All right, then I'm really struggling for room here, so maybe I'll just go up here. So my total angle is going to be the arctangent of the y total over the x total, which is which turns out to be 7.3 7.3 degrees to the right of downfield.